To solve an inequality like this, we have x squared is greater than x plus 6. Now the simplest way to do this, since you will have access to a graphing calculator, is to graph x squared, which you'll see here in blue, and then in the second y equals to graph x plus 6. So I've done that on my graphing calculator, and you see the shot here. If you were to graph it by hand, which you won't be required to do, but some of the advanced students might be asked how you would, you could take x squared and subtract x and subtract 6, and then that'd be greater than 0. And in which case here you'd have the ability to factor. So you would have x minus 3 and x plus 2 is greater than 0. Over here, that would make you cross at positive 3 and negative 2. It's a happy parabola, so all I really would care about is this. You could, of course, find the vertex by finding the midpoint here and plugging it into your equation. And so we would want to be asking then, since you've moved everything over, when is the parabola greater than 0? Well, that would be happening at the times when it's above the x-axis, which would be here before negative 2 and after 3. Now again, this method up here is basically for an advanced method if I asked you how you would solve it by hand, because you would be able to factor. Now, because you'll have your graphing calculator, you can certainly just, like we said, graph blue x squared and x plus 6 in red. Looking at this graph, it's important we find where they meet. So here, this is meeting at the coordinate 3 for x and 9 for y. And then it's meeting right here at negative 2 for x and 4 for y. So there's my intersection. I can find that by tracing on a calculator, or if I graph it carefully, I might be able to see it on the table. So if I want to know when is the parabola greater than or bigger than x plus 6, well, that parabola is above or greater than x plus 6 here, and then you can't see much of it, but here, if our window is bigger, which actually, if you're comparing it to the advanced answer, makes sense. It's on the outside. So for our answer, let's give it first in a number line. You would say negative 2 and positive 3 are my cutoffs. Notice that the gator does not have an equals to, so we're going to leave the circles opened. And now, which way would I shade? If I were to squish this graph, that highlighted area would land on the outside of that 3 on the intersection. So I'm going to shade to the right of 3 and then to the left of negative 2. That's number line notation. If we were going to do this in a gator notation, x is less than negative 2 and x is greater than 3. And in interval notation, that would be from negative infinity to negative 2, soft bracket because it doesn't have an equals to, open circle. Also from 3 to infinity, and soft bracket on both of those. Again, infinity always gets soft brackets. The numbers get soft brackets because it's not equal to and it's an open circle.